Okay, fourth graders, we just had a Module 2 test yesterday, and today we're actually going to take a little detour away from Eureka Math just for a couple days, and I'm going to have us focus on Chapter 5 from Go Math. And the reason for that is because the stuff that they teach in Go Math Chapter 5 is all about factors and divisibility rules and multiplying different math facts and things like that. And it will really help us as in our work as we move forward. So today we're doing Go Math Chapter 5, Lesson 1. And what Chapter 5, Lesson 1 is all about is finding factors. I know we've been talking about factors, right? But today we're actually going to use models or pictures to help us find factors. So our learning goal today is I can use models to find factors. But first let's talk about the problem of the day, which is a review of what you learned in Module 2. So if we look at the top, it says a factor is a number multiplied by another number, right, to find a product. We know this. We talked about this yesterday when we were talking about our factor wheels. 2 times 2 equals 4. What were the factors? 2 and 2. What's the product? 4. So we know that a product is the answer to a multiplication problem. Okay, so in this case, 18 is the product, and 1 and 18 are the factors. Okay? If I know that 7 equals 7 times 1, what are the factors? Everyone?
7 and 1.
Good. If 342 is equal to 1 times 342, what are the factors?
1 and 342.
Exactly. Very good. Now, many numbers can be broken into factors in many different ways, right? If I have the product of 16, I can make 16 in many different ways. I could say, well, 2 factors of 16 are 1 and 16. 2 factors of 16 are also 4 and 4. Or also 2 and 8. Do you guys agree? Yeah. So I'm going to show you how we can use a model now to find all the factors of a number. And right now we're going to find all the factors of the number 24. Okay? So you see a little piece of graph paper there, right? Each box represents one number. Okay? So do you guys see this blue box that they've already drawn for you? How many boxes are in there? How many tiles are in that? I'll tell you that there's 24. Good. And they made 24 by making 2 across, and how many across this way? 12. So the factors are 2 and 12, right? We know that 2 times 12 equals 24, so the factors are 2 and 12. Is there any other way to make 24 a box of 24 tiles? Go ahead and draw it. So if I make a box that has 3 going up and down and 8 going across, I know that 3 times 8 equals 24. So what are the factors of 24 there? 3 and 8. Is there any other way to make 24? Go ahead and draw it in that first area. Okay, I know that 4 going up and down by 6 also equals 24. So the factors are 4 and 6. Okay, I could have also done 1 times 24, right? Do you guys agree? Okay, but I don't have enough room to draw that. So given these 3 different ways to make 24, let's list the factors of 24 from least to greatest. What is the smallest number that you see there? Everyone? 2. Okay, what's the next biggest? 3. What's the next biggest? Okay, then 6, 8, and do you see 24 there? 12. Now, do you guys see there's 2 more spaces? It's because also 1 and 24 as well, right? Do you guys agree? Yes? Okay, so 1 really should be all the way down here. 2 factors that make a product are sometimes called a factor pair. How many factor pairs does 24 have? Let me ask you a different question. How many factors does 24 have? Count them all. 1, 2, 3, 4, 6, 8, 12, and 24. How many factors was that? Everyone? 8 factors. How many factor pairs are there? 4, because 4 and 6 are one factor pair, 3 and 8 are one factor pair, 2 and 12 are one factor pair, and 1 times 24 is another factor pair. Okay, so there's a difference between a factor and a factor pair. They've drawn for you arrays. Arrays are just rows and columns of objects. Okay, so this is an array of tiles. Do you guys see that? If I go like this, that's also an array because I've arranged it into rows and columns. Make sense? This is not an array. Okay? Got it? Okay. You guys have worked with arrays before, yes?
Yeah.
Okay, good. Okay, so we have arrays here that they drew to help you name the factors of 12. So in the very first one, how many tiles are there going up and down? 1, okay. How many factors are there going across? 12. So what factor pair is that? 1 and 12. What about the next one? How many are there going up and down?
4.
Okay, 4. How many are going across?
3.
So what factor pair is drawn there?
4 and 3.
Good. What about the last one? How many are up and down?
2.
Okay, what about the next one?
6.
So what are the factor pairs?
2 and 6.
So how many factors of 12 did we list altogether? Not how many factor pairs, how many factors did we list? Everyone? 6. Let's arrange them from smallest to greatest. 1 is already given to us. What's the next biggest?
2.
Okay, and then 3 is given to us. What's the next biggest?
4.
6 is given to us, and what's the next biggest? 12. Great. Now, how are the numbers 3 and 12 related? See the word says Math Talk? It says, explain how the numbers 3 and 12 are related. Here's a hint. Use the word factor in your explanation. These are examples of how we can use models to help us find all the factors of a number.